So this is a quick video on the 68, 95, 99.7% rule. Okay, so this rule has in its title the numbers that you need to remember, and these are very crucial numbers concerning normal distributions. So basically, if you have a general normal distribution, which I will draw here, and let's say it has mean mu, and it has standard deviation sigma. Yes. So let's say this is there is some random variable, taking some abstract probability space onto this, mapping it onto the real line, and the PDF is the probability distribution is general normal. So it's distributed normally with mean mu and variance sigma squared. Okay, so this 68, 95, 99.7% rule says that there is the probability that x, the probability that, I want to write this better, probability that x is less than or equal to the value of mu plus the standard deviation, but greater than or equal to mu minus the standard deviation. So if this is mu, let's say this is mu minus the standard deviation, and this is mu plus the standard deviation, and we want to ask what is the probability that the random variable is within that interval, i.e. it's less than or equal to this, but greater than or equal to this. Well, that's the integral of this here. It's equal to the integral of the PDF, so let's just say little f of x, between mu minus sigma to mu plus sigma dx. And basically the 68, 95, 99.7% rule says that that is equal to 0.68, which is the 68 part of this rule. Okay, so it basically says that this area here is 68% of the total area underneath the normal distribution. So the area between x, mu plus a single standard deviation and mu minus a single standard deviation is equal to 68% of the total area under the general normal distribution. And that works no matter what mu you have and what standard deviation you have. Okay. So the next part of the rule is that if you want the probability that x is between within two standard deviations of the mean, i.e. that x is greater than or equal to mu minus 2 lots of the standard deviation, but less than or equal to mu plus 2 lots of the standard deviation, then that is approximately, of course, these aren't exact equalities, that is approximately equal to 0.95, the 95 part of the rule. So if we draw a picture again, we have something like this, and we have our mean here, and we have one standard deviation here, and the area under that is 68%, and we have two standard deviations, let's say here, not exactly, should be evenly spaced, but never mind. So this is mu minus 2 standard deviations, and this is mu plus 2 standard deviations, and the 68, 95, 99.7 rule says that the area between this, the integral from mu minus 2 lots of the standard deviation to mu plus 2 lots of the standard deviation of, let's write out the full PDF, it's 1 over sigma the square root of 2 pi e to the negative x minus mu over sigma squared over 2 dx. If you do that integral, it's approximately equal to 0.95, and that's the basis of 95% confidence limits and all of this. Okay, so the final bit is, as you should guess, that the probability that it's within 3 standard deviations of the mean, so x is between mu minus 3 lots of the standard deviation and mu plus 3 lots of the standard deviation, is approximately equal to 0.997, the 99.7% part of the rule. So if I were to extend this picture along here, and go to 3 standard deviations, so this is mu minus 3 standard deviations, and this is mu plus 3 standard deviations, the area under that, which is the integral from mu minus 3 lots of the standard deviation to mu plus 3 lots of the standard deviation of the probability density function dx is approximately equal to 0.997. And so those are just some useful numbers to know if you haven't got readily available statistical tables for looking up the CDF of the standard normal distribution.